And then, do you want my mom to just scan the pages and then she can email them to you, or?
She can try that. She knows how to do that. That's
Yeah.
actually a harder if she knows how to do it, fine. But it's actually harder than taking a picture with your phone. But
Okay.
merely because you have to know where the file is and attach it to the email. But sure, she can do that for sure.
You know how to do that?
She doesn't need to do it right now because we've got quite a bit of information to cover for tonight, I think.
Okay. Okay. Yeah.
Problem
Yeah.
that I have from the book that it's the same book as you use. It's just a different edition.
Exactly.
And the
Yeah.
fact that it's a different edition, mine is old enough now that it doesn't have the same exact problems, but that actually might be a good thing.
It might be. Yeah, for sure.
Okay.
Okay.
Because the ones you have in your book, after you figure out how to do these, you can then go and try to do those on your own.
Cool.
And that's the whole point of this, is to get you so you can do them.
Cool.
All right. So I'm going to back up. We'll get back to this page in a minute.
Okay.
I want to do congruent triangles.
Okay.
Okay. Now, some of the stuff you may have sent me. I don't know. I take these files that my students send me, and I call them certain names and put them in my database. Tell me if you can prove that these pairs of triangles are congruent, and tell me based on which postulate. In other words, let's look at number 3.
Okay. So for number 3, we know that A is congruent to Q, B is congruent to R, and then, so it'd be the AAS postulate.
Good. Number 4.
That'd be the SSA postulate, or side-side angle postulate, and then we know that Z is congruent to L.
Hold on. Hold on.
Yeah.
Back up one second. There is not an SSA postulate.
Is it just ASS then?
Yeah.
And then
let's list the postulates because there's only 5 of them.
Okay. Yeah.
And there's SSS. You know that one. There's only one other one that has 2 S's, and the A has to be in the middle.
Okay.
In other words, you have to have the angle that is both sides create.
Okay.
That's the A. Okay? This one is not a theorem.
Okay.
Okay? Unless and I don't know what to tell you here, it is, if the angle is greater than 90 degrees, you can use SSA. But it has to be greater than 90 degrees. And in this particular problem, it is greater than 90 degrees. And so we do have SSA. And I happen to know that these are congruent because SSA does prove congruency as long as the A is obtuse. Or even 90 degrees. Notice that there's another one. Well, first of all, let's go through the names. And then you have angle, side, and what's the other one that has 2 A's?
The ASA postulate.
And then there's one that has HL. What's that mean?
Height and length.
Well, that's for right triangles only.
Okay.
And if you know you have a right triangle and you know the hypotenuses are the same and either side, then you know you have congruency. And notice what that actually is when you're dealing with a right triangle. That's actually side, angle. Okay, so side, angle works as long as the angle is 90 degrees or more. In other words, if I have this, there's an angle that's more than 90 degrees. And if I have another triangle, and I know that that angle, like say is 95 degrees, and it's the same as that, and I know either of these sides. In other words, that's side-side angle, and they are congruent. And what this is actually side-side angle, but for some reason they don't list this one as one of the postulates. In other words, they don't list SSA. I don't believe they do. Maybe they do. But SSA is only congruent if it's obtuse.
Okay. Then isn't there also like a CPCTC?
Yes. In other words,
would that be one?
Well, is all CPCTC means is that if we have congruence, then the corresponding parts, in other words, the part that's between these two angles is AB, line segment AB, is congruent with line segment QR.
Okay.
Because they're the same corresponding parts of congruent triangles are congruent. So you'll be able to say that AB is congruent to QR. Now, sometimes if they're oriented funny, in other words, flip this thing around, and it's not always easy to tell which are the corresponding parts.
No, it isn't.
On this one here, it's pretty easy. You're not ever going to get confused. But really the way to do it is find the line that is between your two known angles.
Okay,
that's AB, clearly. Well, down here, the line that is between the two angles is QR. So AB and QR are the corresponding parts. Now, over here, we only have side-side angle. So is it possible to prove, if, say, state the postulate or theorem you would use? I don't know what to say to this one here. I happen to know it's congruent because it's an obtuse angle, but I don't believe there is a postulate regarding that.
I don't believe so, I
don't think there is. And yet...
Do you want me to look it up?
Only if you know exactly where all four of your postulates are. Regarding congruency, go ahead and see if you can find one, but I don't think so. For now,
probably not,
let's go on. I don't want to get hung up on that particular problem. Let's look at number 5.
Okay.
Is 5, are they congruent, and why? I don't, you don't have to say according to this postulate. You just have to know why. That's kind of the thing about proofs. You don't really have to know how to prove stuff, but you have to know what it means. In other words, if you have a rhombus, you need to know that the two diagonals bisect one another. Things like that. You don't have to know that that's because of a theorem or a postulate that says they bisect one another. You just have to know. So number 5, are they congruent?
So we know that, well,
I don't know if you can see all of this. That's the single angle hash mark, and there's the angle. So we know this angle here is equal to this angle here, and we know this angle here is equal to that angle up there.
So that'd be...
It's important to know that that's not the same as this.
No, they're alternate from each other.
Well,
So
what do we know?
Well, we
need a third thing that's equal. What is it?
Are Q and S equal to each other? Oh.
No, they're not.
No, they're not.
It's one thing you've missed. I've seen you miss it before. And it's actually the easiest thing. It's the line, the diagonal. PR. In other words, notice that this side right here is common to both triangles. The only difference between this picture over here and this one is if I put these two together, I would only have one line. They would still be congruent because a line is equal to itself. In other words,
Yeah.
so that's equal to itself, so which postulate is it? Or what reason is it that they are congruent?
Wouldn't it be, so for 5, so that would be the SSS postulate, wouldn't it? Because, well, no, I take that back.
Stop and think about what information you actually have. What do you have?
So, P and R are equal, well, like,
no,
are congruent.
So the angles and sides. That's what I mean.
Okay, they're all angles.
No, they're not. That's an angle, that's an angle, that's an angle, and that's an angle, but PR is equal to itself. And PR is a side.
Okay, so
diagonal is a side. So you have 2 angles and a side.
So it'd be the AAS postulate.
Okay, now let's talk about that.
Okay. Does that mean that they're not congruent to each other, the AAS postulate?
No, AAS means they are.
Means they are, okay.
But here's what it means when you have angle side angle as opposed to angle side side. If I know that angle is congruent with another triangle, and I know this angle is congruent with another triangle, and I know that side is the same as that side, it doesn't matter if you go left to right or right to left. Take your 3 pieces of information, you have what?
Yeah, then angle, side, then angle.
Okay.
So it'd be
That's
the
how you
ASA.
get that one, exactly.
Okay.
And it doesn't matter. If I start from the right and go left, I still get angle, side, angle.
Okay.
Okay?
Yeah.
And AAS is the same as SAA. In other words, you can reverse the letters in all of these.
Uh-huh. Okay.
Okay?
Cool.
And
okay.
I might have mistold you at one time that you want to read these things clockwise or counterclockwise. Okay? That's wrong.
Yeah.
Sorry, it was just wrong. Okay.
No problem. Yeah.
And the only time it matters is when you have AAS. In other words, if I know that angle and this angle are congruent with another triangle, I know that side. If I start here and I go around the horn, I get angle, angle, side.
Okay.
But that's going the long way. You always want to go the shortest way between your 3 pieces of information.
Yeah.
The shortest way is not to go counterclockwise. The shortest way is to go clockwise, or right to left, or left to right.
Okay.
Okay? And how you read a triangle, that's all you have to do. In other words, if I know that angle, that side, and that side, read that. What are those 3 letters in sequence?
ASS.
Correct.
Postulate. Yeah.
And that is not congruency.
No.
And I'll tell you why. Because I can draw a triangle like that has the same angle, same side, same that side. And this triangle is clearly not congruent with that triangle.
No.
But the only time I can ever do that, where I can actually draw a triangle that's not congruent, is if that is an acute angle. The moment that angle gets to be 90 degrees or more, then ASS actually works. And that's why in this problem, those are congruent, because that is angle, side, side, or side, side, angle. Notice we don't read this side and then go this way, angle, side.
No.
We're going to read it in the path that's going to get you from the left piece of information to the right piece of information in the most direct manner.
Okay.
And it would be side, side, angle, not side, angle, side. So it does matter whether you go clockwise or counterclockwise in reading triangles. Okay?
Okay.
Go the way that the 3 pieces are closest in information.
Okay.
This clearly is side, angle, angle. Or
Uh-huh.
angle, angle, side even.
Yeah.
Okay, so this one here is what did we figured it was angle, side,
Angle, side, angle.
Okay.
Yeah.
What's wrong with 6? Why can I not say those two triangles are congruent?
So just go there, including that ABCs. Ooh. ABC, A. So no, no.
Why does the person who answered this think they're congruent?
Because all the sides are like marked correctly.
Not sides. Distinguish
Or angles, yeah.
sides.
Yeah. Oh, because it's they said that as the the AAA postulate.
There is none.
It isn't, no.
There's no AAA postulate.
No.
Because on angles, I can have same three angles, much
it just doesn't
triangle.
Yeah, it doesn't prove congruency.
Right. It's similarity is what that is. And if you discuss similarity yet, you will next. In other words, if I have three angles, I have two similar triangles, but I don't have congruent triangles. And similar triangles just mean that the ratios are the same of the congruent parts. In other words, if this is a 3, 4, 5, this is some multiple of that. This might be a 6, 8, 10.
Okay. Yeah, which is, just wrong.
Notice the ratio of that hypotenuse is 2 to 1, 2 to 1, 2 to 1. So when you're dealing with similar triangles, which is only when you have angle, 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 then you can further state that the ratio of corresponding parts is the same. And in fact, all the ratios are the same. Look at these two triangles here. Not only is 10 to 5 the ratio of the corresponding parts, but 10 to 8 is the same ratio as 5 to 4. Within that triangle, this side to that side is the same ratio as this side to that side. And to 6 is the same as 5 to 3.
Which is, it's not right.
Well, no,
they're not congruent to each other.
It's not, it's not congruency, but it's similarity. And I'm jumping the gun a little bit, but you got similarity coming up real quick. I'm sure within the next week you'll be talking about similarity.
Okay.
But I've been wrong before. But you'll definitely get it soon. Okay?
Okay.
So these are the only 5 that we really have to work with in terms of congruency.
Okay.
All right, let me leave this page and let's practice these until I'm convinced you know how to do them.
Okay, cool.
Are those two triangles similar, and if so, based on what? Number 7.
For number, I was looking at that one. Can you use the ABC is congruent to HJK. There's not enough information.
How much information is
there? Well, we know that B and J are 90-degree angles.
How many angles do we have here that we know are the same over there?
2.
How many sides?
Just 1.
So how many pieces of information is that?
3.
Are they in the right order?
No.
Hold on. If I put those 3 pieces of information next to one another, I'm going to start there and go that way, or I'm going to start there and go that way. The only thing I'm not going to do is start there and go around the bend.
Okay.
If I start here and go to the quickest route to get to the 3rd piece of information, what do I have? Angle?
Angle, side.
Angle, angle, side. Same thing up here. Angle, side. And you don't really have to put these, orient them so you know that that angle is the same as that angle. is all you need to know is there's three pieces of information here. They've told us that those same three pieces are up here. So that's all you need to prove congruency. The question is it anything? The only thing that really doesn't prove it, if you have three pieces of information, is side-side angle or angle, angle, angle. Pretty much any other combination of those three letters, and you have congruency.
Okay, cool. Okay. So that'd be angle, angle, side. Okay.
Yeah. Okay. Let's see. To prove these two triangles are congruent, they've told me that GH is the same as MN, and that angle G is the same as angle M.
And then we know that angle...
What other piece of information would I need to prove congruency?
Angle H and angle N.
Okay, that would work. What else?
Or angle F or angle L.
Yeah, pretty much any other angle, right?
Yeah, pretty much, yeah.
If you have two angles and a side, you have congruency, and it doesn't really matter whether it's angle, angles. It says use angle, angle congruence. So that changes it a little bit. Hold on.
Okay.
In other words, the instructions tell us that for this one, make sure you have angle, angle congruency.
Okay.
Well, let me do a quick draw of these. It doesn't matter if it sucks.
Nah, it's alright.
No, I mean, it doesn't really matter if it's not exactly what we're looking at. They've said that GH is the same as MN. So this is the same as that. And they've said angle G is the same as angle M. Now, your first response was that H needs to be equal to N. But if that were the case, what kind of congruency would we have?
ASA.
Right, and they want us to prove it using
AAS.
So which angle do I need to say is the same?
F and L.
Right. In other words, if it's that one, now notice that if I put those in any order, that way to that way, as long as they go from the first piece of information to the third in the shortest path, because I wouldn't want to go angle, side, angle.
No.
I'd go angle, angle, side. That's the shorter path.
Okay.
That's the only way I know how to describe it. I actually got a little confused the first time, thinking that it was based on clockwise and counterclockwise, and it isn't. It's a way to get from your one piece of information to the third piece of information in the quickest manner, starting at either end.
Okay. Yeah.
Okay? All right.
Cool.
So, I would need angle L. Now, if I knew that FG was equal to LM, and that G was equal to M, and then want to use angle side angle, so in this case, I know that FG is equal to LM. FG is equal to LM, and G is equal to M. Oops. And they want me to prove it using angle side angle.
Okay.
Which angle do I need to be the same?
Angle side angle. So it would just be F and L again.
Correct.
Yeah.
All right.
Okay.
Look on. I think you just about have it. Let me find. I mean, I don't want to beat a dead horse, but I think part of the problem is you don't get enough drill on this.
No.
Part of the problem I have as a tutor, and I was realizing this today, was that because I get such a short amount of time with students, I don't really get to tutor them in the way that is the best, which is to find a problem, explain how to do it, and then give them a bunch of similar problems and let you practice doing it. And the ideal way would be, okay, we do one congruency or a couple of different types of congruency. I show you how to do them, and then I give you like 4 or 5 problems on each type of congruency. And that's kind of what we're doing tonight. And the only reason we have time to do it tonight is because we're not racing.
Yeah, exactly.
If you only do, say you were doing a half an hour a week.
Okay.
Well, in that half an hour, your class is making progress. You're doing 5 hours worth of math a week in school.
Yeah.
And so you're moving right along. And in that half an hour, I don't have time to explain a concept and then let you do 3 or 4 practice problems on it.
Yeah, there's just not enough time.
That's the way to do it. So, in a way, this crash course we're going to have for you will give us that chance. And we'll stay as close as possible to your current curriculum. I don't want to go back too far, and I don't want to go too far forward. But we'll make sure you are right on this stuff. I don't want you to find any problems that you do not know how to prove congruency.
Cool, I appreciate that, yeah.
Okay? So this is more typical of the problems you have, as opposed to the previous page. The previous page was fairly straightforward. It showed one triangle and then a separate triangle. The proving congruency becomes a little more difficult when they're all part of the same figure.
Yeah, exactly.
Okay? So let's prove that AFE is congruent to BF or DF.
By the
SAS triangle and that triangle.
Okay.
And prove it by SAS.
Okay. So AFE is equal to DFB. So
we have.
We have. What do you mean?
Well, right now we have 2 sides, right?
Yeah, so we know that A and B are
for that side, and that side's equal to that side. So we got our 2 sides. So we're looking at an angle. Which angle is it that is equal? They tell us that A is equal to B. But would that give us side angle side?
No.
No. We need a different angle. Which angle must it have to be for it to be side angle side?
Angle E.
Not angle E. The angle that the 2 sides make.
The angle that the 2 sides make.
There's one side. There's the other side. This is the angle they make right there.
Oh, okay. So you have to like draw it in.
AFE. You don't have to draw it in, but we know that AFE is congruent to what?
DFB.
Correct, because they're vertical angles.
Okay.
Once I know that angle is equal to that angle, now I have side, angle, side.
Okay. That makes sense, yeah.
Notice that I couldn't actually use that one, because then I would have had side, side, angle.
Yeah,
Okay, although I know that, well, no, that's right. I would not be able to use that. The only way I really have to prove congruence here is to those angles have to be the same.
Okay.
Because side-side angle definitely does not work if you have acute angles. I mean, it works if you have a right angle or more, an obtuse angle, but notice we don't in these 2 triangles. I mean, there's the right angle, but that's not the angle that's in this triangle. Angle AEF is acute. So I would not be able to say side-side angle works.
No.
Okay, so number 12, AED, this triangle, a different triangle than before, and BDE, and we want to do it by angle, angle, side. So let's find two angles, first of all.
Okay. So let's see. So AED, so let me find that. So AED, angle, angle, side. It's equal to
Well,
BD.
there's one angle staring you right in the face.
Yeah.
Let's start with those. The ones we don't have to do anything to.
Yeah. So angle A, yeah, angle B, like
A and
we
B.
know that. Yeah.
There's one angle.
Mm-hmm.
Okay. Where's the second angle?
E and D.
Correct.
And then,
but you have to make a little bit of a leap here. In other words, that's a right angle. And that's a right angle, but that's not the triangle we're trying to prove congruency with. We're trying to prove congruency with this triangle. But the fact that that's 90 degrees means that BDE is also 90 degrees.
Yeah.
You can't have a 90 degree on one side of a straight line and not have 90 on the other.
Yeah, exactly.
They're a linear pair.
Okay.
The pairs are always supplementary, so they have to both be 90.
Okay.
And now we know angle B and angle EDB. So there are two angles.
Okay.
And which side?
Then it's like right in the middle, like right under F. Is that side?
ED?
Yeah, ED, my bad. Yeah.
ED because it's common to both triangles.
Exactly.
Not because it's this one over here.
No.
This triangle actually has nothing to do with these two these first two questions.
Yeah, it's totally separate.
Okay. And finally this one. AED, again that same triangle. But this time they do want you to prove congruency with this triangle over here. By ASA. So let's find our two angles.
Okay. So we could do ED, so angle E, side ED, and then angle D. And then that'd be the ASA postulate. And then
how do you know that this angle here is the same as this angle over here?
We don't.
Actually, it's not those two.
No.
Let's see. We don't know that A is equal to this one right here.
Yeah.
In fact, we don't know that at all. But notice there's parallel lines here.
Yeah.
That's critical. What does that tell us?
That they're supplementary, linear to each other.
Well, let's stop for a moment. We've got, whenever you see parallel lines, the key is to be able to find the transversal amid all of these other lines that you're looking at.
Okay.
Hold on. Use my mouse. Okay. In other words, here's the triangle ADE, and here's the triangle BCD, or BD, whatever. Yeah. But the fact that that's parallel to that makes this line right here a transversal. Also, that line a transversal. Okay? So there's certain things. In other words, can you separate out the parallel lines? There's the two parallel lines. There's the transversal. So what do we know about this angle and this angle?
They're like supplementary to each other. Or no, they're corresponding.
They're corresponding, which means they're congruent.
Congruent to each other.
Okay, between us, we can use equal and congruent in the same way. There's a slight difference between the two words. but not important. If you use equal instead of congruent, I have no problem with it.
Okay, cool.
But the fact is that makes this angle C, this, I can't call that angle D, that's angle EDA.
Okay.
But that's the same. And the right angle is the same. So there's our two angles. In other words, that angle right there and that angle right there, along with this angle here and this angle there, because they're both right angles, and the side that's right in between both of them.
Okay.
That side there.
Yeah.
And that's angle, side, angle.
Okay.
So we had to use the parallel line aspect.
Yeah, we did, yeah.
And like I said, the difficulty there is almost separating out all these other lines. In other words, if we're going to view this in this manner, I've got to eliminate this from my picture and I've got to eliminate that from my picture. Now, that happens to also be a transversal, and so is that. So I could make some assumptions about other angles here, but they're not part of our triangles here.
Okay.
In other words, I do know other things about other angles, but as long as I'm dealing with this triangle and this triangle, then that angle is the easiest one to prove is equal to that angle because of the parallel lines and the transversal.
Okay.
Okay.
Cool.
Just review parallel lines and transversals because I want to focus really on the principles that you're going to have to deal with over and over.
Okay. Yeah.
What other angles is 1 equal to?
Angle 1 is equal to angle 8. Angle 1 is equal to angle 5.
Okay.
And then angle 1 is equal to angle 4.
Good. Cool. Now let me make that exact problem slightly more difficult.
Okay.
In other words, now you can't tell any difference between acute and obtuse angles.
No. So we know that 1 is equal to 4.
Okay.
1 would be equal to 5.
Okay.
And that 1 is...
Because these are equal because they're vertical.
Vertical, and then 1 and 5 are corresponding.
Right.
And then 1 and 8 are alternate exterior.
Good. 3 is equal to what?
3 is equal to 2.
Okay.
3 is equal to 6. 3 is equal to 7.
Good. You understand parallel lines in those angles.
Yeah.
And the trick, the only time you're ever going to get messed up is when you got all kinds of other lines going in there at the same time.
Okay.
Because it's hard visually. It's hard to notice here, well, what's the transversal and what angles are only made by the transversal? Notice that this angle right here, all the way around, in other words, angle B, would be equal to this angle here.
Oh, okay. Yeah, that makes sense.
Because they're corresponding angles.
Yeah.
Right? In other words, that's a big obtuse angle, that's a big obtuse angle. And there's your transversal. So frequently the secret is just to notice there's a transversal and then try to determine which angles are equal to one another by that transversal.
Okay.
All right.
Cool.
You feel confident on congruency, or should we do some more congruent stuff?
I feel pretty confident on it.
Okay.
Honestly, yeah.
Let's go on to this page.
Sweet.
We've got 15 minutes tonight. Let's talk about quadrilaterals, which is you're still on quadrilaterals, is that right, in class?
Yeah, in Rhombus all that, yeah.
You had that today? Yeah. So you got quadrilaterals, which generally encompass rhombuses, rectangles, and squares.
Okay.
Okay?
Yeah.
And next chapter, you're going to get into kites and diamonds.
Ooh, okay.
Also quadrilaterals. But
Okay.
not rhombuses, rectangles, and squares. So,
Okay.
what's the definition of a rhombus?
So the definition of a rhombus are two congruent. Well, yeah, they're well, all four of them are four sides of them are
That's
yeah
all you
are
need. And there's very few rhombuses. A square is
okay.
a rhombus.
Uh-huh.
But if
Anything.
I tilt it into a parallelogram,
Uh-huh.
I still have four equal sides.
Yeah,
So
exactly.
when I have four equal sides, I always have a parallelogram.
Uh-huh.
No
Yeah.
matter, I don't always have a square, but it's
Mhm.
always at least a parallelogram.
Okay.
You can't
Yeah.
draw a four equal sided figure without having a parallelogram.
Okay.
Okay?
Yeah.
And
Okay.
more importantly, there's something else about this. If I draw diagonals, there's
Uh-huh.
a property here. There's two properties that we need to know about. When I have
Okay.
a rhombus, not a parallelogram, because this isn't necessarily true with a parallelogram that's like this. In other words, there's a parallelogram, but it's not a rhombus.
No.
Okay?
No.
If I draw
Okay.
diagonals here, I can make no such statements that I can make
No.
when it's a rhombus.
Yeah.
What can I say when
Yeah.
it's a rhombus? I can say two things
You could say that
regarding the diagonals.
so it makes up two triangles.
They bisect each other.
Yeah, there's like a midpoint, right?
They bisect. It's
Okay.
important you know what bisect means.
Yeah.
Bisect means split into two equal parts.
Uh-huh.
Okay, so
Yeah.
that line is equal to that line
And
because
then
this diagonal
yeah.
bisected it.
Uh-huh.
And that diagonal bisects this diagonal, so that line is equal to that line.
Mm-hmm.
Okay?
Yeah.
And
Okay.
one other thing, not only do the diagonals bisect one another, but what else are they?
Uh well there's a mid
They're perpendicular.
they're perpendicular.
That's the two things
Because
to remember about a rhombus.
Because they form two right angles then, right?
Right.
Like at the center there, yeah.
In other words, as long as one of those four angles is right angle, you have two perpendicular lines.
Okay.
All four of them are right angles. In other words, you can't have that without also having that, and that.
Uh-huh.
All of them.
Yeah.
But the two things about a rhombus is the diagonals bisect one another and they are perpendicular.
Okay.
Neither of
Yeah.
which is true if it's not a rhombus. If it's just a parallelogram, they don't bisect one another and they're not perpendicular.
Okay.
At least I don't think
Yeah.
they bisect one another.
I don't think so, yeah.
They might, actually, now that I think about it.
They might.
Kinda, but I don't know. I don't want to get into problems that I don't know the answer to yet.
Yeah.
I don't mind going there eventually, but that's a
Uh-huh.
rectangle with a diagonal.
Okay. Yeah.
Prove to me that the top triangle is congruent to the bottom triangle.
Yeah, so it would be congruent to C because those diagonals, I guess, meet up. Well, no, they don't meet up.
Okay, first of all, let's stop and see. We need three pieces of information.
Okay.
We either need three sides, we need
Uh-huh.
side angle side, we need two angles and a side.
Uh-huh.
There's all kinds of pieces of information in this picture. First of all,
Okay.
that's a rectangle. What does that mean?
That all the four sides are congruent to each other.
Well, not
Or
four.
like, well, they're like equal to each other, I guess you could say.
Opposite sides are equal. In other
Okay.
words, AB is equal to CD.
And they're like perpendicular to each other, like.
And BC is equal
Okay.
to AD. AD is not equal to AB. This is a rectangle, not a square.
Yeah.
So there's two pieces of information, two sides.
Okay.
Do we have a third side? I mean, since we found two sides already, the easiest way to prove it is if the third side is equal, we're done.
Yeah, which would be B. Well,
what's the third side?
So we have two sides already.
Okay, I'm going to draw this triangle, this picture slightly different. I'm going to do it for effect. And the effect is going to be so that you see this thing.
Oh, because it splits. Okay.
You're inclined not to see it.
Yeah, I can see. Yeah.
When I separate the two triangles, you see it.
Yeah, two triangles. Yeah.
Is equal to this side.
Yeah. Yeah.
That's because there's a common side to both triangles.
Okay.
Always look for the common side.
Okay.
That's the one you have a tendency to miss. Okay.
Okay.
But there's all kinds of things going on here. Because it's a rectangle, I know that's parallel to that. So which angles are equal?
So the AD is equal to BC.
Angle.
And then
angles.
Angles. So okay. So angle B would be equal to angle D.
Okay. And both right angles. Okay.
Yeah.
So
and then
that. Yeah.
And then angle C would be equal to angle A.
That's actually enough because that gives me side, angle, side.
Angle, side. Yeah.
Okay. So that proves congruency. What about based on the parallel lines?
Based on the parallel lines.
Yeah. That's parallel to that because it's a rectangle.
Yeah.
And here's my transversal.
Okay.
So based on that transversal, tell me two angles that are equal to one another. Three-letter descriptions.
Oh, okay. Well, we know that BAC is equal to DCA. Wait.
Correct.
Yeah.
This one here. BC is equal to that one there.
Yeah.
DCA, exactly.
So,
in other words, the fact that we had a rectangle and a diagonal gave us like 5 pieces of information. Because we also know this angle here is equal to that angle there.
Okay.
Because of the parallel lines. So I know that angle's equal, that angle's equal, that angle's equal, that side, and that side. This is one of the few cases where you have side, 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 angle, angle, angle.
Wow.
In other words, you can prove that all 6 things are congruent.
Wow. Okay.
So you can actually make all, and it even fits the HL theorem. In other words, this picture here, you can use any of the 5 postulates to prove it.
Okay.
If we told you, prove these are congruent using all 5 postulates, you'd be able to do it because you have all 3 sides and all 3 angles. So you could pick and choose. You still there? I heard a beep, and it indicated I might have a little audio difficulty, but you can hear me okay?
I can hear you. Yeah, can you hear me good?
Yeah, everything's
fine. Okay, cool. Okay.
Okay. So,
let's
go back.
Okay.
And look at some of these.
Okay.
Quadrilaterals.
Cool.
Give me another name for an equiangular quadrilateral.
A square one.
Okay.
Or a rectangle.
Or a rectangle, exactly.
Yeah.
But not a parallelogram.
No.
Not just any old parallelogram. Give me another name for a regular quadrilateral.
That would be like a parallelogram.
No.
Or like a rhombus.
What does regular mean?
Well, like the sides don't have to be congruent to each other.
Regular actually means equilateral and equiangular. In other words, regular means all same sides, all same angles.
Okay.
That's what regular means. If you have a regular hexagon, It doesn't just have to be six-sided. It has to be 6 equal sides, 6 equal interior angles. So that's what regular means. So regular quadrilateral.
A regular, yeah, that makes sense.
What is one? Give me another.
For like a regular quadrilateral. Quadrilateral, gosh. So because like a square has to be like all equal or like congruent sides.
4 equal sides, 4 equal angles. What is a square?
4 equal sides and like 4 equal angles.
That makes it regular.
Oh, okay. So like a rectangle would be like an example of that.
Not a rectangle. A rectangle doesn't have 4 equal sides. Notice that. That rectangle has only 2 pairs of equal sides.
Yeah.
But the top is not equal to this. But with a square, you have the definition of regular. 4 equal sides, 4 equal angles.
Okay. Yeah, that makes sense. Okay. Cool.
Let's talk about rhombuses a little bit. Now let's go down and use some of this. Let's do a little algebra.
Okay.
That's a square.
Yeah.
What's x?
So x would be. Would you do set 5x equal to 360?
Not 360. What angle is that?
Right angle. So you do 5x is equal to 90.
Okay.
Okay. And then that would be
x equals 16, I believe.
16.
No, not 16. 90 divided by 5 is 18.
18, yeah. Yeah. Okay, cool.
Oddly enough, this measurement right there, but that was we didn't need
coincidence.
Well, we don't need that. That's an irrelevant piece of information for this problem. To find x, we don't need that 18.
Okay.
Over here, we know it's a rhombus.
So would you set 130, or would you just do 360 minus 130 divided by 3?
No. It's
Where's that?
Rhombuses, opposite angles. Remember, rhombuses are parallelograms. Always.
Yeah.
It's just the parallelograms that have 4 equal sides. Well, let's talk about parallelograms. Just in general, what are the properties of a parallelogram? If I draw a parallelogram like this, what do I know about angles 1, 2, 3, and 4?
2 and 4 are equal to each other, and 3 and 1 are equal to each other.
Okay. So in this case up here, I know that G is equal to E. I know
and then
F is equal to H, and they're both 130.
Yeah.
So which what must be true between these two? Adjacent angles are supplementary, always in parallelograms.
Okay. Yeah.
In other words, 2 plus 3 is 180. 3 plus 4 is 180.
Okay.
1 plus 4 is 180. And 1 plus 2 is 180. In other words, adjacent angles.
Okay.
Okay? Okay. So, those two are adjacent, so that makes the problem really easy. Well, how much is x?
180. Wait, so adjacent. So what's the definition of adjacent again? That's like
they're angles that are next to one another.
Okay. Notice, so F
next to one another. 3 and 4 are adjacent. 1 and 4 are adjacent. 1 and 2 are adjacent.
Okay.
So all of these combinations are supplementary.
Equal, dude.
Not equal. Adjacent are not equal. 1 is not equal to 2.
No. So they're
supplementary. They add to 180.
Okay. Yeah.
That's how we know. So what is x? If
130.
F plus
you do
E add to 180. So what is
Okay. So that would be 50 degrees.
Okay. There you go.
Okay, that makes sense.
What's the sum of all four angles in a quadrilateral?
360.
Okay. So
Yeah.
this and this couldn't possibly add to 360.
No. No. Yeah.
All right. All right.
All right.
That's a good hour session. I feel like this was a little more useful than last time.
It was, yeah. I don't know why the pictures wouldn't send you. That's odd.
We can get around that.
We can, for sure.
Because I have the same book, even if I have different exercises, they're similar enough that they're testing you on the same principles and questions.
Okay.
Okay.
Cool.
Exactly the same. Yeah. So we can get by even if your camera can't send pictures to me.
Okay. Awesome.
So we're set for 5 o'clock tomorrow and Wednesday. I had a cancellation on Thursday. If you would rather do this at 5 than 7:30, I can move you up.
Sure. Yeah, let's do that.
Let's do that.
Yeah, that sounds good. All right. So 5 o'clock on Thursday.
Mom, because I think I had originally told your mom 7:30, and
okay.
I'm sure this works for her also.
Yeah, for sure. Right. Awesome.
Right. I'll see you the next 3 days at 5.
That sounds good. Thank you.
All right, Dylan. Have a good one.
You too. Bye-bye.